And I've started the recording, and here's our first question. And if you can't do it, you know what that means. That means that you're a failure. Here we go. And this is 3.9, number 11. 3.9, number 11. I'll write it on the board for you. Is it a test question? Yes.
You have a work email.
D over dx of the natural log of x over 5 natural log of x plus 4. Now, what can we do? What would your initial feelings be? I'm asking y'all to talk.
I think I would rewrite the natural logs.
I'm sorry, say again?
I think I'd rewrite those natural logs.
Well, actually, yeah, you could. You take the natural log of both sides, but it would be a little bit redundant because you've got a natural log in there. And the 4 is not a natural log. So, what else? What is this? It's a what? It's not a natural log because the 4 is not a natural log. So we can't say it's all a natural log, but what is it? Starts with an F. Say again?
Fraction.
It's a fraction. What do we do when we have a fraction and doing derivatives? Starts with a Q.
Quotient.
The quotient rule.
Quotient rule. So let's do the quotient rule. Denominator, and I'm going to go up here using the quotient rule.
Priority 1 message coming in on secure
And
channel.
make sure that ain't somebody's been thrown out of class.
You have a work email.
Sorry about this. Somebody about a dropped student. So that's going to give us 5 natural log plus 4. 5 natural log plus 4, denominator, times numerator prime. Numerator prime is going to be natural log of x minus bracket, and then we're going to have numerator times denominator prime. Well, what is the derivative of the natural log of x? So that's going to be 5 times 1 over x. Oops, got my blue. And let me just do this. Write it in blue. So that's going to be 5 natural log of x plus 4. So now we're going to have 5 over denominator 5 natural log of x plus 4 raised to the second power. Say again?
What happened to
I'm going to do it on the next step. Does everybody got a question? Okay. So 5 natural log plus 4. Now I'm going to take the derivative of that minus brackets, and that's going to be natural log of x, and parentheses or brackets, that's going to be 5 times 1 over x. All right, now start cleaning it up. Miss Sterling, did Mr. Sword show up, or is he? Okay, he's here. Okay. Miss Sterling, you're sitting in the dark. I can hardly see you. There, now I can see you. All right. Now, actually, this is not going to... Say again?
I can't do anything about the sun.
I know. Sounds like a song, doesn't it? I can't do anything about the sun.
Is that a song, or are you just about to start to sing something?
What?
Is that actually a song?
No, I just said it sounds like a song. I can't do anything about the
break
song.
out into a sing song.
It does sound like it. I think I'm getting it mixed up with Here Comes the Sun. Minus, well, that's going to be 5 over x times the natural log of x. 5 over x times the natural log of x, and you could put the 5. So you could basically put everything over x, correct? So that's going to be 5 natural log plus 4 minus 5 natural log of x over x. And what happens to the 5 natural logs? This is a nice one. I like this one. So your derivative is 4 over x. I like that.
About the denominator squared.
Say again? Oh, shoot. I forgot about that. Dadgummit. I should have followed my notes. I didn't do the, so much for that. 5 natural log I need to bring some posters in here. 5 natural log of x plus 4 quantity squared. So that's going to be all that over, I'm going to make this small. Of course, it's not going to cooperate, but I'm going to make it small anyway. So that's going to be all this over 5 natural log of x plus 4 quantity squared over 1, which is going to give you multiplied by 1 over 5 natural log of x plus 4 quantity squared. So that's going to give us 4 times 1 is 4 over x times 5 natural log of x plus 4 quantity squared. That's the final answer. Sorry about that. That's why I keep my notes. I should keep them, but I don't. Now, hopefully, y'all are finding out that it's called, for when you do things over and over and over, practice. Yeah, practice. And that means that some of you should be, and you don't have to say anything or raise your hand, okay? Miss Sterling, be quiet. Most of you should be getting better at these. You're gonna stay quiet, aren't you, Miss Sterling? No comments.
I mean, you asked nicely this time.
Okay. But most of you should be, you know, and that's a good thing. Kind of like playing the piano. The more you play it, the better off you are, or the better you get. Unless you just really are, unless you really suck at it. All right, next one. That's a good test question also. All these are good test questions. This is number 17. Number 17. I'll rewrite it for you. Y is equal to, notice they write it in a function. What did I tell you that was a hint of? Y equals 8 to the negative x times the sine of x. What did I tell you that they were hinting when they do this? If they give you a function, what should you think about? You don't have to do it, but what should you think about? Taking what? The
Log of both sides.
log of both sides. Taking the natural log of both sides. You don't have to do that. You can do this one 3 ways. Taking the log of both sides would be the number 1. Since it's written in a function form, I would probably take the log of both sides. I'm going to put a parenthesis here and here because you're going to have to do the product rule and the product rule. No. Yeah. Take the derivative of this first times the derivative of the second plus the second times the derivative of the first, and then you're going to have to do that with this also. So go ahead and work it out. Well, the natural log of 8 is a number, right? So that's kind of like 3x, right? Yes, Hubert. Is this the same as negative 3x? Is these two the same, not mathematically equal, but are they the same type? A number with an x? Yes. So you can take the derivative of that. The derivative of 3x is negative 3. So what is the derivative of negative x times the natural log of 8? Technically, it's the natural log of 8. Okay, and when you do the product rule right here, first times the derivative of the second plus the second natural log of 8 times the derivative of the first. And what do you get? Negative natural log of 8. So if you did the product rule or if you did the power rule, you're going to get the same thing. What's the derivative of that function? Well, it's going to be negative natural log of 8. But anyway, first, it's going to be 1 over y times y prime is equal to first times the derivative of the second. What's the derivative of cosine? Forget it. Plus the second times the derivative of the first. The derivative of negative natural log of 8x is negative natural log of 8. Now, the only thing you can do now is just multiply by y on both sides. You might be able to factor out a natural log of 8. You could factor out a negative natural log of 8. But let's go ahead and multiply by that. So I'm going to multiply by y. And I'm going to multiply this by y. And y is equal to 8 negative x sine of x. And you can distribute that out if you want to and take that 8 to the negative x on the bottom. Let's go ahead and do that because all this is algebra. So that's going to be 8 to the negative x times the sine of x times negative x natural log of 8 cosine of x plus 8 to the negative x sine of x times sine of x negative natural log of 8. Now you could factor out this 8 to the negative x can come downstairs. So that's 8 to the x. And this is 8 to the x. So that can do that. And once you can do some more, the negative or the natural log of 8 can come out. You can play with that. I'm looking to see, let's see, I got negative natural log of 8. That'll come out. And that will leave you with cosine, yeah. So that would be natural log 8x on the bottom. You're going to get some stuff canceling out. You're going to get sine plus cosine on the top of that natural log of 8. I'm looking to see, well, that sine, the sines cancel. There it is. What's sine? The sine right here, the two sines are going to cancel. Because this is together. Oh, come on. I'm going to put this in blue. That sine of x, that's together with that. And this sine, there's supposed to be a sine cancel. That negative can come out right here. This is confusing because the negative right here can come out with this negative sign and cancel with this negative sign. So one of the signs cancel with that negative right there. The natural log of 8 can come out, and that's going to leave you with the natural log of 8 with cosine of x and the sine of x natural log. That's going to cover it. Now, as you can see, the natural log process is a little bit more complicated. Okay? Just remember this, because in the next two problems you're going to see it come out. Okay? Unless I made a mistake. I think I got it. I think I got it on target. Okay? This is the only one I didn't do. I did quotient rule, and I did, what else did I do? I did the product rule and I did the quotient rule. I did both. Okay? I didn't do the natural log. I just threw the natural log up there today. So let's do the quotient rule next.
What did you say the final answer was?
We'll get to that in just a second. Hold on just a second. Just go to the next page and I'll give it to you, but I don't want to write it down yet. That's why I don't want to give it to you. It's cosine of x, parentheses, 1 minus natural log of 8 times the sine of x over 8x. And we'll get to that in just a minute. Now, if you take this problem, what'd I say, quotient rule or product rule? What'd I say?
Quotient rule.
Quotient rule. So that's going to be sine of x over 8 to the x. All right, try that. Find the derivative of that. Don't take the log of both sides, just take the derivative. And of course, you got y is equal to this. So if you take the derivative of y, you get y prime. That's not a big deal. And that's going to be denominator times the numerator prime. What is the derivative of the sine? Minus the numerator times the derivative of the denominator, which is going to be 8x natural log of 8 over denominator squared. All right, go ahead and start working with it. You can see that the 8x is going to, 8 to the x, sorry. 8 to the x is going to come out. It's a whole lot easier doing the product rule and the quotient rule than it is doing the natural log. There we go. So denominator times numerator prime minus the numerator times the denominator prime over the denominator squared. That 8x comes out. 8 to the x comes out. I'm just going to pull it out because I want it to cancel with the bottom. And that's going to leave cosine of x minus sine of x natural log of 8 over 8x raised to the second power. But that right here cancels with this one and makes 8x. And that's what I was telling you to look for. There's our final is a whole lot easier to do it this way. We'll do the product rule next. Okay? Y prime is equal to the cosine of x minus natural log of 8 times the sine of x. And if you work with that other, the natural log, if you work with it, you'll get the same answer. But it's just, usually when I get to the natural log and I'm doing a problem and the natural log gets too hairy, I just pull out of it and do the, do the product rule or the quotient rule. And that's a whole lot easier. The quotient rule, I think, is the easiest one to use on this one. All right, go ahead and do the product rule. Now you got to be careful with the product rule. And I'll show you why in just a second. Go ahead and do the product rule with this one. Can anybody tell me why the product rule might be a little trickier? Anybody want to take a stab at it? Why the product rule might be a little trickier? It's in the original write-up right there. It's right there, staring you in the face. Anybody want to take a stab at it? What really makes you cringe when you see that the way it's written?
The 8 to the negative x.
Okay, the negative x. What's the derivative of negative x? Negative 1. And that negative will mess you up. Something happened. Did somebody leave?
They're still on it.
I saw it flash. Somebody, I hope somebody didn't get kicked out. I saw the box flash up and then I saw, okay. So first, times the derivative of the second. The derivative sign is what? It's cosine, plus the second, which is sine, times the derivative of what? The first. Oh gosh, we might as well quit. Well, 8 to the negative x times the natural log of 8, then the derivative of what? The derivative of what's inside is what's the derivative? Negative 1. And that negative 1 right there, let's go ahead and paint that. Let's paint that that negative 1 right. Oh, shoot. One day, training. One day. Negative. Will that negative 1 cause you a problem? Yes, it will. All right, clean it up and finish it. What's the first thing you're going to do, people? That's not rhetorical. I wanted y'all to interact with me. Besides quitting, what's the first thing you want to do in cleaning this up?
Factor out an 8 to the negative x.
And do what with it?
Put them on the
Factor out.
denominator.
It's 8 to the
Put it in the
negative x,
denominator.
so you want it to go where?
The bottom.
Denominator.
By downstairs. Now you can do that as 2 8 to the negative x's. You do it as 2, or you can just say, well, I'm going to factor out, but I just make this one denominator of what? 8 to the x. Okay? Now you can go through the steps if you want to, factoring it out and bringing it down. You can. That's fine. I don't care. That leaves you with the cosine of x. And I'm just going to mark this out right here. I'm going to mark that out. I'm going to mark this out. And that negative right here will come out front. So here, I'm going to make this magenta, negative magenta. I'm going to make a magenta negative because that represents that negative 1. And that's where you'll get the problem wrong. And you can write sine of x times the natural log of 8. Or you can say natural log of 8 times the sine of x. That should be what we got the last time. So here, you've done the product rule, you've done the quotient rule, and you see that the natural log can be a little bit more messy on this one. Okay? So, that's why it's so important for you to do these problems 2 or 3 ways so you can see where you hit the brick wall. And when you hit the brick wall algebraically, sometimes you might want to back up and say, well, let's try product rule, or let's try the quotient rule. Capiche? Yes, capiche, Hubert. Thank you, class. And let's check, see what their answer is, so y'all can feel good about yourselves. So you won't have to be the short. They interviewed that short guy. Did y'all see his interview?
No.
No.
Okay, forget it. That's all right.
Today?
Everybody's weaned on a pickle today. I don't know what's wrong with y'all. Didn't I show y'all the short guy yesterday getting beat up in the bagel shop?
You did.
Oh, I watched that video.
They interviewed him.
Oh, man.
That boy, he's mad at the world. Okay, there it is. Cosine of x minus sine x, natural log of x, 8 over 8x. Don't y'all feel good about yourselves? Yes, Hubert. No,
Yes.
Hubert. We suck, Hubert. I know y'all do. Miss Gusmus, you talk to me. Won't you talk to me?
Sure, what you want to talk about?
Nothing. I want to talk about the short dude. You didn't say anything about the short dude, so.
Yes, I did. I said I didn't see his interview.
Oh, we'll have to watch it because it's on. I saw it on. No, I don't know where I saw
I
it.
didn't see it.
Somebody have to look it up. Okay, we got an official Google. Mr. Swords will look it up for us.
Right
All right,
on.
this is our last question today. 3.937. 3.937. Good question. Let me see how I did this one. I think I did this one by the quotient rule. Yeah, you don't want to. No? I don't have this one. Did we do this one?
Yeah, we did.
We already did that one. I think I did that one for y'all yesterday and did it 3 different ways.
You
I got
did.
number 11. Okay, number 11. Hold on. Thank goodness I wrote it down. There it is. Okay, this one we haven't done, right? Y'all look at it. I don't think we've done this one.
Today? That's the very
We
first
just
one.
did that. That was the first one we did today.
Oh, okay, so we're done. Okay, I'm sorry. Okay, so that's all the questions that were sent today. Thank you. All right, now, let me erase those 2 so I don't do them over again. I did all of these. Okay. All right, I'm not crazy. I'm not drunk. Yeah, I am. I'm drunk. I'm sorry. So let's go to my whiteboard. Okay, that's it. That's all of Unit 2. Okay. Yes, we had 3 tests, but the reason we had 3 tests is because it's really almost 2 units. But anyway, let me go to the whiteboard. That is what we're going to study now. Okay? And the best way to study that is to go to the basics right here. I don't know why this thing's not covered. This is chapter 5. So until further notice, we're going to do chapter 5 next. Okay? I'm not worried about chapter 4. All right, what are we doing?
So we should disregard chapter 4 in reading?
Yes, disregard it until later date. All right, I'm going to, now I want to show y'all a comic strip, and I always do this with my calculus class, so don't feel like y'all are special or anything. What's the Foxtrot? Foxtrot.
Comic.
Yeah, but I'm trying to think about Foxtrot comic. Integration. Well, let me go to the images. There it is. All right, I'm going to blow it up where y'all can read it. I know somebody's going to sit there and go, I can't read it, I can't read it. All right, this guy, what's his name? I don't even know his name. But he's sitting in there, and the question is, Farmer Bob's vegetable garden is 20 feet wide by 30 feet long. Calculate its area in square footage. Okay? Now, there's 2 ways you can do this. You can do it by length times width, which you learned back in pre-algebra, or you can do the integration of y is equal to 20. Y is equal to 20 from 0 to 30. Okay? So, and a lot of people sit there and go, okay, well, that's that. I have no idea What's that squiggly line mean? I don't know what that means. He's evaluating 600 square feet. And then it says, call me Mr. Rigorous. Jason, here's your quiz from last week. Okay? In other words, you can find the area of a rectangle either by basic geometry or you can find it with calculus. Now, of course, this is overkill because calculus can find the area under a curve. Everybody with me? The area under a curve. Write that down. Calculus dash, well, let me just draw this. Let me just draw this because this might make more sense. Calculus is divided into two things. Calculus, Calc 1 especially. Two things. One, the derivative. And the derivative gives us what? Well, it gives us the tangent line, the equation of the tangent line. It gives us the increasing and decreasing. It gives us the inflection points, which we've already covered, and it gives us the speed and velocity. Okay? Everybody knows that, right? And the other thing, which is the opposite of the derivative, is the antiderivative, or the integral. And the integral gives us area. Okay, everybody with me? So you have spent Unit 2 finding how to find the tangent. Now we're going to spend Unit 3. Which one was it? Unit 3? Whatever. Okay? You're going to spend Unit 5. This was Unit 3. Now you're going to spend Unit 5 studying the opposite of the derivative, which is the antiderivative. Okay? That's why I wanted to shoot to Chapter 5, because it's most important that you understand it. Very good, and I'm going to drill it from here to the last day of class, which we don't have very much, but we meet every day. So, we got a little bit of time. All right. Now, let's go back to the Wolfram. And, looking under a triangle, like this triangle in green, I can get my area by using two triangles. This triangle and this triangle right here. And I can find, no sneezing in class, and I can take 2.5, this is about 2.5, isn't it? 2.5 down here, and this is about 2.5 right here. 2.5 times 2.5, multiply that, that's your area there. And then technically you can take this 2.5 and this 2.5, and that's the 2.5 right there. So 2.5, 2 times 2.5 squared, what's that going to end up being? Well, it's going to end up getting an area. Now that's the way you do it with geometry. Everybody with me? Or we can take our limit theory and we can take a bunch of hair, the width of a hair, rectangles. And we can change those triangles into what? Rectangles. And notice each time what's happening with the triangle at the top. Each time I add a rectangle, what happens to the triangle? It gets what? Smaller. That triangle is called your error, or error, depending on where you're from. See? Now it's getting smaller. Now it's very important that you see this, because I'm going to turn these rectangles right now that you think are 2.5 units long or almost a unit long, I'm going to change them into the width of a hair by using the limit theory. We're not going to get into it like we did with the derivative, but get closer and closer and closer and closer. That width of that big green rectangle is going to turn to the width of a hair. And when that width of a hair is created, this error in this triangle is going to be so minute that you're not going to even notice it. So there's that triangle. Then I'm going to increase it again. I'm going to increase it to another one. And that's going to make that triangle what? A little bit smaller. Now I'm not doing this to piss you off. I'm doing it because you need to see what's happening here. This is Riemann's sum. Okay? If I get these triangles small enough, I can take these rectangles and I can get the length and the width and I can multiply them by 4 or multiply them by 5. That's Riemann's sum. I'm not going to spend a lot of time on Riemann's sum because I think most of you can understand that if I make this a triangle, let me show you. If I make this a triangle, I'm trying to find, I don't use this very often. Let's go with a green triangle or a green rectangle. If I make this a rectangle, and I make this a rectangle, and I make this a rectangle, and then I figure out the average and I say, well, I take that, I think to minimize the triangle here, I'm going to bring this down a little bit, and I'm going to take this triangle and I'm going to add it to this rectangle, and I'm going to add it to this rectangle, and I'm going to add it to this rectangle, and I'm going to find the area under this curve by adding up these rectangles. Does everybody understand that concept? This rectangle plus this rectangle plus this rectangle, that's called Riemann's sum. And I add this one up, I add this one up, I add this one up, I add this one up. Okay, that's Riemann's sum. We're going to skip Riemann's sum and we're going to jump right into integration. Okay, and I make it a little bit small, a little bit bigger. I mean smaller. See, my triangle gets a little bit smaller. Oops. Well, y'all see the point. I'm going to make it smaller, and then look. Watch what happens when I make them real small. Watch those triangles. Now that's not the width of a hair, but we're going to take our handy dandy black marker and I'm going to draw a triangle now. That little triangle right there is a whole lot smaller than this triangle right here. Now, if you take these right here, and let's just say that each one of these green lines is a rectangle. That's the width of a hair. You're talking about a minute triangle at the top of that green line. Does everybody understand that? Miss Sterling, do you understand that?
Not really, but I'm reading the text.
What about Mr. Let's see. How about Mr. Howell? Do you understand that?
Somewhat.
Somewhat. All right, well, I'm going to try it again. Watch this. I'm going to take and I'm going to expand this. And I'm going to change it to a parabola. Okay, does everybody see the error there? Okay, I want to find the area in green under the curve, but look at that. That's a mess. So I need to make it smaller. Make it smaller. Using my limit theory, I'm taking my rectangles with the triangle top and I'm making them thinner. And look what's happening. What's happening to my error that was huge? It was huge. What's happening to it?
Get smaller.
It's getting smaller. The error is getting smaller and following the contour of the what? The curve.
But the error will never get all the way down to 0, right?
Yeah, but where will it get? Where will it get, Mr. That's what I want you to see. The arrow will never reach 0, but it'll get very what?
Real close.
Real close. And unless we're designing O-rings on the space shuttle, we don't need to worry about, how close that's going to get. Okay? And you can make these, and when you get down to a width of a hair, when you get down to the rectangle being this width of that green line right there, you're talking very, very, very little error. So, what does that mean? Well, that means in order to do this, we have to take the antiderivative. Now, everybody agrees that this is a quadratic, right? X squared. Okay, I'm going to show you how we do a antiderivative. And I'll just write on this. The antiderivative is shown by the squiggly line, like that. That's called an integration symbol. A to B. A's on the bottom, B's on top. That means the parameters, like this is 0 to 5. Okay? 0 to 5 is where I'm going with this. So 5 would be B and A would be 0. X squared. X squared is the function. Now, I don't see the actual, I would like to use, but I'd have to go and I'd have to find the vertex. I'd like to use this one, but I can tell it's got a horizontal shift of 2, so that's going to be x minus 2 quantity squared. So that's x, hold on a second. I'm going to try to get as close as I can. X minus 2 quantity squared plus, I don't know, plus 0.5 maybe, plus 1/2. Okay, so that's the way this would be set up. All right. Now, we've got to do a little bit before we can actually do this problem because we don't know the rules yet. Okay, I wish I could move that down to, but we'll go over to something else. I'll just make one up, okay? Because I think it would be better if I made one up. Because if we tried to take the derivative of that, antiderivative of that, it wouldn't be pretty. So let's go to the whiteboard. And let's do, my son was playing on the whiteboard while we were there. Sorry about that. Okay, so let's do x squared. F of x is equal to x squared. And we all know that this looks like this right here, right? Everybody agree with that? And we all know that this point is 0, 0. And this point is 1, 1. And this point is 2, and this point is 4. This point is 3. And this point is 9. Everybody with me? So I'm going to draw a line straight down, and I want to find the area under this curve from 0 to 3. From 0 to 3. Okay, I want to find the area under that line. So what I do is I set up my integration, or my antiderivative, from 0 to 3 of x squared dx. Now, the reason I have to add the dx is that's important. The reason I have to add the dx is because I'm taking the antiderivative of something that you took the derivative of. Okay? That's why you have the dx there. All right? Later on, it's going to mean a lot. It means delta x, which is going to help you out later on. Okay? So always put the dx there. Now how do you take the derivative, the antiderivative of x squared? We learned how to take the derivative of it. That would be 2x, wouldn't it? Yes, that's not how you take the antiderivative. You take the antiderivative by doing the opposite of the derivative. X to the 2 plus 1 over 2 plus 1. Instead of subtracting 1, what are you going to do? You're going to add 1, and you're going to put it on the bottom. So that's going to give us x cubed over what? 3. And now you're going to evaluate that from 0 to 3. Now that line right there, I want you to make a note. Take your highlighter or whatever, and I want you to highlight this line. This line means evaluate. And evaluate from your algebra a long time ago means you're going to plug and what? Plug and chug. And you always subtract. Now, I'm also dealing with this antiderivative. This right here is called a definite integral. A definite integral means that you have parameters. What is my parameters with this definite integral? 0 to 3. Okay, that defines a definite integral. An indefinite integral doesn't have parameters. And we'll get to that in just a minute. So now I'm going to go over here and I'm going to write my function in terms of parentheses, because I use parentheses because I don't want to make a mistake. And we always subtract. And let's highlight that. I'm going to highlight that subtraction symbol the same as the evaluate, because that's what you do. Okay, you always what? Subtract. Think about it like this. If I travel from Anderson to Greenville, okay, and my odometer says 30 miles, then if I want to find out how far it is from Anderson to Greenville, it's going to be 30 minus 0, right? So you're always going to subtract. So somebody plug in 3. 3 is your biggest number, so it goes in first. So I'm going to put in a 3 right here. There's your 3. I'll plug that in right there. And then my 0, I'll color it red. I don't like to use red, but ooh, it clashes with that magenta. And I get, actually I get 3 to the 3rd power, which means one of them is going to cancel out with the bottom, so that leaves 3 times 3, which is 9, minus 0, which is 9. So the area under this curve from 0 to 3 is 9 square units. That's called the antiderivative. Now that's where we're going with this. Okay, I want to show you what an indefinite integral is compared to a definite integral. Because I'm not giving you any homework tonight. All of your assignment tonight is to finish what? 3 things. 3.9, 3.10, and what? The test. So let's move on to the indefinite integral before y'all start turning into pumpkins, because I've got like what? 10 minutes or 5 minutes?
10.
See, I get interaction when it comes to my time limit. I just don't get interaction after that. Y'all know how to hurt a guy. Y'all know that? No response. Okay, so let's do 2x to the fourth. This one is called an indefinite integral. You do not have a lower and upper bound. This is just like me, asking you what is the square root of 5, and you say, or square root of 25, you say 5. Okay, I'm not going to do any evaluation. I'm just wanting you to tell me what the antiderivative is. Okay? That 2 can come out because it's a constant. So you will go 2 times the antiderivative of x to the fourth dx. Now you want to take the derivative of this guy. I'm sorry, the antiderivative. So you add 1, so that's going to be 2 bracket x to the 4 plus 1 over 4 plus 1. And that's going to give you 2 bracket x to the 5th over 5. And then that's going to give you the final answer, which is 2 fifths x to the 5th plus c. Now, why in the world do you have to add a c? And is that important? To some calculus instructors, oh my gosh, they go into a frenzy if you don't put the c. Why? What's the derivative of 2x plus 5? I'm telling you why. Hold on. What is the derivative of 2x plus 5? d over dx. What is it? What is the derivative of 2x minus 7? What is the derivative of 2x minus 1/2?
You have to account for the constant, right?
You have to account for the whole family, okay? What is the family? This is the derivative of 2x family. Is there only 3 in the derivative of 2x family? No. There's millions, billions, infinity, and beyond, okay? So you have to account by that by saying this is an indefinite integral for a x to the 5th family or x to the 4th family. I'm just going to put a family. Okay, and family is in quotation marks, and that's why you have to put the c. C's are only for indefinite integrals. Question, gripe, complaint. Now, you have just learned the first rule of antiderivatives. It's called the power rule. You add 1 on the top, and you add 1 on the bottom. This right here is your calculus right here. That's called the power rule of antiderivatives. Power rule of antiderivatives. You pull out the constant. What about if I gave you the derivative, and this is where I told you before, when in doubt, write it out. Remember me telling you to write out x to the first and x to the 0? Well, what if I gave you, find the antiderivative of x plus 4 dx? Well, the first thing you do, if you ever get confused, write it out. The antiderivative of 1x to the first plus 4x to the 0 dx. Now, one of the rules, just like derivatives, if I have 2 terms, can I take the derivative of those 2 separate terms and that'll be okay? Yes. It's called the sum rule or the summation rule. So I'm going to take the integral of 1x to the first plus the antiderivative or integral of 4x to the 0, put a little dx here, put a little dx here because some teachers will have a fit if you don't put that dx. And now I'm going to say x to the 1 plus 1 over 1 plus 1 plus 4x to the 0 plus 1 over 0 plus 1. Now what does this first term come out to be?
X squared over 2
1x squared over 2
plus 4.
plus 4x to the first. And that 1/2 x squared, you can write that as 1 over 2 and then x squared beside it, or you can write it as x squared plus what? C. Now luckily, I don't know about this one, but I know Webaside had the C outside of the box where you answer. I don't know because it's the first time we've used this. We're getting used to it. So I don't know what they're going to have when I assign the homework. I'm not going to do their homework. It'll be Hubert's 5.1 homework. I haven't loaded it yet, so don't try to do any, okay? So that's how you do. And if I did now, what about rewriting things? Should you rewrite things like you learned in derivatives? That would be a hail to the yes. Okay? So let's do an example. This will be the last one. I don't want y'all to turn into pumpkins. F of x, or antiderivative of the square root of x to the third power dx. The first thing you should even think about, what's the first thing you should say to yourself? I got to rewrite it because I can't deal with fractions. With radicals. So antiderivative of what? X to the exponent over index dx. Now finish it. Oh God, it's a fraction. I can't do that. X to the 3/2 plus 2/2 over 3/2 plus 2/2. What's 3/2 plus 2/2? Are we finished? No. You're going to rewrite that reciprocal. 2/5 x to the 5/2 plus c. Antiderivative of 3x to the -1 dx. In this case, you don't have to rewrite it. You just have to think. 3x to the -1 plus 1 over -1 plus 1. That 3, you can bring it out front. I should have done that. That 3, you can bring out front here. It's a constant, so you can bring it out here. Okay? And then that'll be that right there. And then that's going to be 3 what? Oh shoot, I picked the wrong. Hold on. Change this to a 2. That's going to be natural log. I don't want to do that. We don't even know about the natural log yet. I picked the wrong number. Sorry. That's to the -2. Let's change that to -2. All right, y'all. We haven't learned natural log yet. So x to the -2 plus 1 over -2 plus 1. Sorry, had a brain bubble there. And what's -2 plus 1? That's equal to 3 brackets x. -2 plus 1 is 1 over -2 plus 1 is 1. And the answer is 3x plus what? Let's see.
Negative.
What?
Hubert,
-1. Sorry. Negative. Thank you. Oh, that's -1 too. Sorry. I just might as well quit. Okay, so that's going to be 3x to the -1. That negative times that's going to be -3 x to the -1. And what do we do with that -1? Take it downstairs, Hubert. And you can put that negative out front if you wanted to. Make it -3 over x if you wanted to. It doesn't matter. Thank you for correcting me on that. Sorry. -2 plus 1 is -1, not 1. Oh. So basically, what did you learn today? Okay? From 5.1, you learned 4 things. 1, you learned that a definite integral has parameters, and it will give you what? Under a curve. The area under a curve. Okay? You learned that the indefinite does not have parameters, and what does it have to have on it when you write the answer? Has to have a plus C. You also learned about the power rule, and you learned that rewriting is imperative with antiderivatives just as it is with derivatives. Now, from here on out, that's what we're going to be talking about, antiderivatives, for the next 4 or 5 days, whatever long, I don't know what day it is. Today's Tuesday, Thursday, Friday, Saturday, Monday, Tuesday. For the next 4 days, that's what we're going to be talking about. And I'm going to try to get as much as I can in. And your test for Unit 5 will consist of whatever we cover up until the 23rd, which is Tuesday, right? I think it's Tuesday. Heck, I don't know. We'll talk about that Monday. All right. Any questions? Nobody's going to say a word, are they? I don't understand what I've done to y'all. I really don't. Did you send our